Have you ever wondered how a pressure reading from a field transmitter appears on the operator's DCS screen? By the end of this video, you will understand every step in that journey. This video shows a conventional hardwired DCS architecture, the foundation used across most process plants today. Your pressure transmitter starts a complete signal journey through field cables, marshalling cabinets, an analog input card, the controller, and the DCS network before the operator finally sees the process value. The journey starts with PT 101, calibrated for a range of 0 to 16 bar. 4 milliamps represents 0 bar and 20 milliamps represents 16 bar. The 4 milliamp value is called the live zero. It tells the DCS this is a genuine zero reading, not a broken wire. A signal below 4 milliamps indicates an open circuit or wiring fault. At 12 milliamps, the pressure is halfway through the span, 8 bar. Every pressure value within the calibrated range produces a proportional current. The transmitter sends its 4 to 20 milliamp signal through a shielded instrument cable. The cable runs to a junction box in the field, where multiple instrument cables are collected. From there, a multi-core cable carries all signals to the control building. Correct cable shielding and grounding practices reduce electrical noise and keep the measurement stable. The field cable enters the marshalling cabinet. This cabinet organizes all incoming instrument connections using labeled terminal blocks. Cross-wiring routes each signal to the correct DCS cabinet. Depending on the installation, the cabinet may also contain safety barriers, isolators, or surge protection. This arrangement simplifies testing and future maintenance. The signal reaches the analog input card. The module measures the incoming current and converts it to a digital value. The DCS then scales that value into engineering units. At 12 milliamps, 50% of span, the result is 8 bar. A quality indicator is also attached to every measurement, showing whether the signal is valid. The controller PIC 101 receives the pressure value from the analog input. It compares the measurement with the configured set point. The controller calculates the required output according to its configured control action. When pressure deviates from the set point, the output changes to bring the process back to target. Quick check. If the field cable from PT 101 develops an open circuit, will the DCS still receive a valid pressure reading? Think about it. The answer is no. The analog input enters an open circuit or underrange condition. The DCS marks the measurement as bad quality and applies the configured fail-safe strategy. It must not be used as a valid pressure reading. The controller shares process data through the DCS network. Modern systems use redundant communication paths. In a correctly designed redundant system, the backup path maintains communication if the active path fails. Operators continue receiving process information without interruption. The operator station receives fresh process data from the DCS network. Measured values, quality status, and trend history all update together. Operators can see whether the pressure is an alarm and whether the signal quality is good, all without visiting a single field instrument. The controller also sends output signals to control the process. PIC 101 sends a command to the analog output card. A 4 to 20 milliamp signal travels to the valve positioner on PCV 101. The positioner compares the requested position with the actual valve stem position and adjusts the pneumatic actuator until the valve reaches the command. This forms the closed control loop. PT 101 measures process pressure. PIC 101 compares the measurement with the set point and calculates its output. PCV 101 adjusts to move the pressure toward the target. PT 101 then measures the new condition. This measurement and correction cycle repeats continuously at the configured controller execution rate. PT 101 converts process pressure into a 4 to 20 milliamp signal. The live zero at 4 milliamps represents true zero, not a wiring fault. The marshalling cabinet organizes every field connection before it reaches the DCS. The analog input card digitizes and scales the signal. PAC 101 compares the measurement with the set point and controls PCV 101 through the valve positioner. The operator station displays real-time values and quality status. This is a conventional hardwired DCS architecture. Modern plants may also use remote I/O or field bus, but the measurement, processing, and control journey remains the same. Subscribe for more OT and instrumentation videos.